Statistics 3, central limit theorem. Type 2, central limit theorem and graphs. So here we have a question context with quite a few bits to it, okay? So we have a company installs new machines for packing peanuts, and we're told the company claims that the machine fills packets with a mean mass of 500 grams and a standard deviation of 18 grams. To test the company's claim, several samples of size 40 packets are taken, and their mean masses x bar grams are recorded. So we have to describe the sampling distribution of the mean and explain our answer referring to the theorem that we have used. So the first part of the question, what we need to look at is the fact that the sampling size is greater than 40. So we say as n is greater than or equal to 40, as n is greater than or equal to 30, we say that the sampling distribution is approximately normal by the central limit theorem with mean equal to, and we can see up here we're told the mean mass is 500 grams. So because of the central limit theorem, the sample means will be the same as the true population mean there, which is 500 grams, but it'll have a new standard deviation. And the standard deviation, of course, is found by getting sigma over root n. So that, in this case, will be, well, our standard deviation, we're told, is 18 grams over the sample size, which is 40. So the new standard deviation is going to be 2.846. Okay, so that's part 1. So what does part 2 want us to do? Well, it says write down the mean and the standard deviation of the distribution of x. So our mean will be 500 grams and our standard deviation, well, I've already worked that out, that's going to be 2.846, and of course I should have grams there as well, okay? So part 3 then says draw a rough sketch of the sampling distribution. So if we draw a rough sketch, well, we know it's going to be normally distributed. And we know what the mean is. So our mean is 500. We know what our standard deviation is. So if I do one standard deviation away from the mean, I'm going to add on 2.846 to that. So that's going to be 502.846. If I go 2 deviations away from the mean, that's going to be 505.692. And I go 3 deviations away from the mean, well, that's 508.538. And then if I go 1 deviation below the mean, that would be 497.154. And if I go 2 deviations below the mean, that would be 494.308. And then if I go 3 deviations below the mean, that would be 491.462. And this is all in grams. Okay, so that would be our mean. That would be our mean plus 1 deviation, our mean plus 2 deviations, our mean plus 3 deviations. This would be our mean minus 1 deviation, our mean minus 2 deviations, and our mean minus 3 deviations. Okay, or if I was looking at it from a z-score perspective, we would have 0, 1, 2, 3, minus 1, minus 2, and minus 3. Okay, All right, so we've done our rough sketch. So it now says find the probability that the mean of the distribution of the sample mean is less than 496. So 496 is approximately here on our graph, and we want to look for the probability that the mean is less than that. So we're looking for all of this area of our graph. And again, in order to find that, we're going to need to convert our value for x, in other words the 496, into a z-score. So let's do that on the next page. So what are we looking for? We're looking for the probability that x is less than 496. So of course we need to change that into our z-score, but because we're looking at a sample here, we have to use the standard error of the mean. In other words, looking at our central limit theorem, we said that that's okay. And our standard error of the mean is always used for samples, and that's page 35 in our tables. So if I sub in my value, so 496, the mean we were told was 500. Our new standard deviation we've worked out to be 2.846 because that's 18 divided by root 40. So you can put in the 2.846 either. And if I get that, then that's approximately minus 1.41 for my z-score. So in other words, the probability that the sample mean is less than 496 is going to be the same as getting the probability that z is less than minus 1.41. Now, of course, if we sketch our graph, and I just look at it from the perspective as a z-score, that's minus 1.41. And I'm looking for all of that area. Well, I know from my tables, if I add in my tables again, that I cannot get a negative z-score. So instead what I have to look is the symmetry. So that is the same as greater than 1.41. But of course we can't find greater than 1.41 in our tables either. So if I look at less than 1.41, well, less than 1.41 plus the red area must equal 1, and therefore if I get less than 1.41 and I subtract it from 1, I will get the red area. In other words, finding the probability that z is less than minus 1.41 is the same as getting 1 minus the probability that z is less than 1.41. Okay, so if I go to my tables here and I look for 1.4 I should say, sorry, and I go out to 1 and I go down, well, I end up with 0.9207. So that's 1 minus 0.9207, which is of course 0.0793. So in other words, the probability that x, the sample mean, is less than 496 is 0.0793. Okay. And there we have the last part, which is what sample size n is required so that we have the probability is greater than 0.06. So the probability, I'll go back, that the sample mean is greater than or equal to 503 is equal to 0.06. Okay, so again, what we need to look at is what is that going to be equivalent to? Well, if we sketch that, it's quite a small probability, and greater than, so it's going to be to the far right. So we want to know what z-score is going to give us the probability of 0.06. So of course, again, I can't find 0.06 in my tables because it doesn't go that far small. So I have to look for less than Z1, which would be all the green area, and then I can take that away from 1, which will give me my red area. Okay, so in other words, I can say that that is the same as getting the probability that Z is greater than Z1. In other words, it will be equal to 0.06. But of course, that's the same as getting the probability that Z is less than Z1, which would be 1 minus 0.06. So I'm taking the 0.06 away from the 1. Okay, well, if I take that away, what do I get? Well, I get 0.94. And again, if I go back to my tables on the previous page, and I'm looking for 0.94, okay? So 0.94 0.94, here we go. So 0.9406, so that's 6 above. And then we have 0.934 is actually 6 below. So it's neither closer to one or the other. So it's exactly halfway between. And I go across, well, that's 1.5. And it's halfway between 0.05 and 0.06. So therefore that means that Z1 must be 1.555, okay? So it's halfway. Exactly. Okay. All right, so that's my Z. So I then know my standard error of my mean. Well, the standard error of the mean on page 35 is Z is equal to the sample mean minus mu over the new standard deviation. And if I sub in my value, well, I've just worked out Z to be 1.555. My sample mean was 503. My true mean was 500. My new standard deviation is going to be 18 over the square root of the sample size. So if I turn that upside down and I multiply, that's going to be 3 times root n over 18. And of course, if I cross multiply, well, 3 goes into 18 6 times. So we have root n is equal to 6 times 1.55. And again, we want to square both sides to get n on its own. And that gives me n is equal to 87.0489, which is basically 87. Okay. So what I'm going to get you to do now is go to page 147 on exercise 5.1 in book 2, and you're going to do question 1, 2, 3, 5, 6, 7 and 10. So that's 1, 2, 3, 5, 6, 7 and 10. Okay.